Hello kids! In this video we are going to learn how to make homothecies to segments, and also at the end of the video I am going to show the same process but with an actual polygon, and you will see that it is not something difficult. You can apply the same process and it's going to be really straightforward. Okay, so we are going to start by drawing 2 points which are going to be the tips of our segment, and I am going to select this tab and this tool in order to draw the segment. You can do it anywhere in the Cartesian plane, but I prefer doing it in the first quadrant, but remember, it doesn't matter where you do it. And as you can see here in this tab, if it doesn't appear, you can uncloak it from here. In this tab you can see the coordinates of the 2 points and actually also the length of the segment, but we are not going to do it for now, and we are not going to need it for now. I prefer to have the coordinates next to the point, so I am going to click in the information of the point, these 3 points, the tab of configuration, and in this part I am going to see valor. I am going to click valor, and that is going to change the letter for its coordinate, and the same for this one. Yes, so now I have 2 different coordinates for 2 points of one segment. You know that this usually happens to me, don't worry about it. To move the plane you always use this tool. Okay, so we have the 2 coordinates. The coordinates are 4,12 for point A and 8,6 for point B, point A and point B. And now we need to decide on a scale factor. Okay, scale factor is the same thing that we previously called similarity ratio or a proportionality ratio. Which for simplifying purposes it's going to be only a number. It could be either 1, 2, 3, 4, 5, any number. It could also be a fraction or a decimal, but I am going to do it in this case only with the number, let's say 4. My scale factor in this case is going to be 4. Okay, so it is really similar to the process that we made when we created similar figures before. We multiply the coordinates by the scale factor, so we multiply it times 4. What is 4 times 4? It is 16. 12 times 4, it is 48. 8 times 4, 8 times 4 is going to be 32, and 6 times 4 is 24. These new coordinates are going to be defining the new segment that is a homothesis of the original. They are going to be the coordinates of the tips of the image of our first segment. So we have 2 options to create to create those points in the plane. We can look for them. We can select this tool in here, and we can place the points wherever we need them. For example, 32 32 and 24. Okay, 32, 24. It's going to be here. Let me select the tool. 32, 24. And as you can see here in this window, those are the coordinates. Okay, but you also have this option to create it. Here we have it. Here you just have the option of writing the coordinates of the point here. And let's do it with the other point. The other point is 16,48. So we write parentheses 16,48, and it creates the point 16,48. So we go here, we click valor, and there we have it. Now we can join it with the tool segment, and this is how you create a homothesis of a segment or a dilation, because you can also find it with that name. Okay, so as you can see, it's like shading light from the origin of the Cartesian plane through here, and I am going to confirm it to you by drawing some lines. If I make a line from here to here, you see, and from here to here, and let me make some changes. The same with this. You can see that these dotted lines are like the shadow or the light, okay? Remember the example of the light that I showed to you during class. It's like you have the light here, here you have the figure, and this is the shadow, okay? So you can also do it with segments, with polygons. So I am going to erase everything by reloading the page, and I am going to create polygons. I am going to do it of course with a triangle because it's easier. Yes, and I am going to do it also. Valor, valor, and valor. Here you have the coordinates. So let's do it again. In this case, I am going to select another scale factor. Sorry, that happened to me once again. This is kind of difficult to manage. Sorry about it. Once again, valor, valor, and valor. We have to get used to select this tool before we do anything else, or things like that could happen. Okay, so we have three coordinates. We have we have 3,3, we have 4,5, and also 6,2. Sorry about it. Also 6,2. Okay, and my scale factor is going to be in this opportunity just 2. I want to keep it simple for this one. So if we multiply everything by 2, you get that 3 times 2 is 6, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, 10 times 2 is 12, 2 times 2 is 4, and these three coordinates are the coordinates of the vertices of our new triangle, which is similar to the original, and it is a homothesis projected from the origin of the Cartesian plane. So I am going to use this method because it's faster. So I am going to write all of the coordinates here. 6, 6. The other one is 8, 10. And the other one is 12, 4. Okay, and now we see, okay, here's a new triangle. Let's do it with a polygon. Okay, the shapes for now look the same. They look like they are similar. So let's actually confirm it. This angle measures 81.87, and the corresponding angle measures, yes, the same. Let's do it with the others. 60.26, 60.26, yes. And obviously the last angle is going to measure also the same than the corresponding one. Let me select this tool and let me move it a little bit so you can see it. You see? The corresponding angles measure the same. And it's like making a projection with a light from the origin of the Cartesian plane to that. Let me make the lines a little bit prettier. Stilo. Okay. So you see, it's like you have a light here, you have this triangle, and this is the shadow. Okay? But if we move it, what happened? Now they are not related, they are not actually connected. But you can do it by using this tool, and you can actually do it in any place of the Cartesian plane. Let me do it with this polygon, this random polygon that I am creating right now. And let me put a point, because that is the thing, those are the things that you need for creating a homothesis. Now you can select this tool. Here in this part you can select Homothesia, and it tells you to select the object, later the center of homothesis, and after that you have to provide a scale factor. So let's do it. Select the object, select the center of homothesis, and a scale factor can be anything. So I am going to decide to do it with the number, actually 1.5. Let's see. Okay, look, we created a new figure, and if I move this one, you see that the other one moves along with it. Okay, because it is like casting the shadow. If I move the point, also the image moves because it's like moving the light. And if you don't see it properly, if you don't see that they are connected, let me do the lines. It's gonna be a little bit long, but don't worry. Oh god, it's going to be really a lot of things, but you can see it. If I move the point, oh, sorry, one was missing. Now if I move the point, the center of homothesis, you see that everything is connected, and the vertices of the original are always connected through the vertices, to the vertices, sorry, of the image. Okay? And the figures are similar. Always scale that up by a factor of 1.5. Okay? If I move the original figure, the image also changes. Okay? If I move the place of it, it's going to be the same.